We've already finished part A of this problem, so I want to start this video with part B. We're going to find q prime of 7, where q of x is f of x divided by g of x. So that's a quotient. So q prime of x is going to require the quotient rule. So we're going to show the AP reader that we know the quotient rule. We know it's bottom d top minus top d bottom over bottom quantity squared. Then we're going to show the AP reader that we're going to find q prime of 7. So we know it's the output of g at 7 times the slope on f at 7 minus the output on f at 7 times the slope on g at 7 all over the output of g at 7 squared. So again, we just need to find all of those pieces, put them into our quotient rule, and we'll have our answer. So here's our point of origin, here's our x-axis, here's our y-axis, our units 3, 4, 5, 6, and 7, and 2, 3, 4, and 5. So let's go about filling in all those pieces. The first one we're going to do is the output on the function g at 7. It's that point right there, so it's 1. The next thing we need is the slope on f at 7. I think this here, this 0.34, is it's a good point to get the slope on that piece of f. We see that it has a rise of 1 and a run of 1, 2, 3, 4. So that's 1/4. The next piece we need is the output of the function f at 7, which we can see from the graph is 5. And then we need the slope on g at 7. We can use the 0.71. We could also use the 0.43. So here we're going to have a fall, not a rise, but a fall of 2. So that's going to give us -2. And we have a run of 1, 2, 3. So that slope is -2/3 over the output on g at 7, which we already said was 1. So this turns out to be 1/4 plus 10/3. If this was a free response question, we would stop right there. We wouldn't even try to find a common denominator. We wouldn't do any more mathematics work. So 1/4 is equivalent to 3/12. 10/3 is equivalent to 40/12. So this is 43/12, and that answers our question. So now you can see how to do these types of problems. I do want you to show all of these steps. I want you to show all the steps to the AP reader, because I don't know where there are going to be points attached to the process of answering this question. So we're going to show all our work so we don't miss any of those process points. They're not after this. They're after the process. There are going to be more points attached to the process of how to get to that answer than there are actually going to be attached to the answer itself. So make sure that you show all of the steps in your process. And our final example that I want to work here has to do with a composition function. So when we take the derivative, that's going to require the chain rule. So it's the same type of idea, but instead of the product rule or the quotient rule, here's a graph problem for the chain rule. This says if f and g are the functions whose graphs are shown, let u of x be defined as f of g of x. Find the derivative if it exists. If it does not exist, explain why. So they want us to find u prime of 1. So again, in the interest of doing the same type of thing that we did on the last problem, we're going to show the AP reader that we realize that we're dealing with the chain rule. So we're going to find u prime of x. Our inside function is g of x. Our outside function is f. So it is the derivative of the outside, not changing the inside, times the derivative of what's inside. So we've shown them that we understand it's a chain rule problem. Now they want u prime specifically at x equal 1. So again, we're going to show them that we understand that this is the process we're going to go through. So we need the output of g at 1, and whatever that value is, we're going to plug that into the f function, and we're going to find the slope at that value. Then we're going to multiply that by the slope on g at 1, so whatever that value is. So let's just start with the output. First of all, let's find our point of origin. Let's find our axes, so we make sure all these values are correct. Let's label our axes. Once again, luckily for us, all of the tick marks are at 1 unit apart. But I warn you, don't count on that. I've seen all kinds of unit jumps, not just 1 unit at a time. So we're interested in what's happening on these functions at x equal 1. We want the output of function g at 1. That's this point right here. And we can see that that value is 3. The next thing that we'll do is we'll go ahead and we'll find the slope on g at 1. We could use this point here, those 2 points. We could find the rise over run there. We could use this point and this point up here. It doesn't matter which. But we can see that we have, let's use this point right here. We have a fall of 1, 2, 3, and a run of positive 1. So the slope on the function g at x equal 1 is negative 3. Now the last thing we need to find is we need to find what the slope on the function f is at x equal 3. Now we move over here. We come up to the point on f where x equals 3, and we want this slope. So again, we just need to find points that we can find the rise over run. Here we have a fall of 1 and a run of 1, 2, 3, 4. So that slope is negative 1/4. So u prime of 1 is positive 3/4. So now I think you wouldn't have any kind of a problem answering these types of questions. Frankly, these questions show up a lot more often on the multiple choice part of the exam than they do on the free response part of the exam. So make sure that you are really meticulous when you do this kind of work.